Elite Wushu is a sport defined by extreme margins and relentless biomechanical demands. Athletes are required to generate massive vertical thrust, launching into the air while simultaneously processing complex spatial positioning. Once airborne, they must execute flawless rotational mechanics and stick perfect landings, all while their bodies are drowning in severe metabolic fatigue. This chart illustrates what happens when fatigue takes over. Technical execution predictably breaks down. Here is the first failure node, a sharp drop in aerial jump height as energy taps out. This triggers the second failure, compromised trunk stability, leading to wobbly landings. Mechanically, this breakdown happens because the athlete's lower limbs are no longer able to produce maximal explosive force under a heavy cardiovascular load. Simultaneously, as the aerobic system redlines, the central nervous system struggles to synchronize the motor units required for fine-tuned physical coordination. These specific physiological deficits are exactly what judges penalize on the scorecard. Correcting them requires a conditioning stressor explicitly designed for the demands of the sport. The standard strength and conditioning approach for martial artists often relies on steady-state circuit training, keeping the athlete's heart rate hovering comfortably around 60 to 70% of its maximum. While this builds baseline cardiovascular fitness, a moderate intensity protocol fails to inoculate the athlete against the severe, acute metabolic spikes of an actual routine. High-intensity functional training, or HIFT, applies a completely different type of multimodal conditioning stress. It combines Olympic weightlifting derivatives, explosive plyometric drills, and metabolic intervals, demanding high muscular output with minimal rest. We are going to deconstruct a recent 12-week randomized controlled trial that tests this exact protocol, measuring HIFT directly against standard conditioning to assess its impact on explosive strength and endurance. Once we unpack the performance data, we will translate these clinical findings into a precise 3-step integration roadmap for coaches. This is the consort flow diagram for the study, establishing a strict randomized controlled trial architecture. Researchers tracked 60 male Wushu athletes, dividing them evenly into an experimental group and a standard control group. To isolate the exact effect of the training style, both groups trained 3 times a week for exactly 60 minutes a session. The control group was assigned a standard conditioning protocol. This consisted of standard resistance work, bench presses, squats, and deadlifts, strictly capped at a 60 to 70% maximum heart rate. The experimental group performed high-intensity functional training, pushing their intensity thresholds up to 90% of their maximum heart rate. Instead of isolated lifts, their protocol utilized sport-mimicking movements like single-leg squats, cleans, and intense as many rounds as possible interval structures. By perfectly matching the total training time between the 2 cohorts, the researchers successfully eliminated volume as a confounding variable. Therefore, any divergence in the final week 12 performance data is the direct result of the specific multimodal stress applied by HIFT. This chart compares the baseline metrics against the week 12 improvements. The experimental group, shown here, clearly outpaces the standard training group across multiple variables. Looking first at muscular endurance, the HIFT group achieved massive gains in upper body capacity, posting a highly significant effect size of 1.34 for push-up performance. Coordination-related endurance saw an even sharper spike, with jump rope outputs yielding an effect size of 1.72. These specific adaptations occurred because the 90% max heart rate and intense work-to-rest ratios force the athlete's muscles to tolerate severe peripheral fatigue. The data shows parallel gains in explosive and aerobic power markers. Standing long jump metrics, a direct indicator of lower limb power development, recorded an effect size of 0.90 for the HIFT group, and 30-meter sprint times, measuring pure acceleration, improved with a 0.93 effect size. Meanwhile, the athletes restricted to the moderate 60 to 70% heart rate zones achieved comparatively minor improvements across identical testing metrics. The HIFT protocol triggered robust adaptations, proving that athletes can simultaneously upgrade both aerobic stamina and pure anaerobic power. The critical question for a conditioning coach is how these surrogate markers, like push-ups and broad jumps, translate to preventing competitive Wushu deductions. By programming Olympic weightlifting derivatives like the clean and jerk, the protocol heavily loads the stretch shortening cycle, forcing the body to convert downward kinetic energy into raw upward thrust. That increased vertical impulse directly solves the first failure node, giving the athlete the peak height required to complete complex aerial rotations. Additionally, unilateral dynamic loads, such as single-leg squats, force extreme pelvic and trunk stabilization. This precise core stability is what corrects the second failure node, preventing the body from collapsing or wobbling during a high-impact single-leg landing under fatigue. Finally, increased jump rope efficiency and sprint acceleration point directly to optimized neuromuscular synchronization. The nervous system fires motor units faster and more efficiently. Together, these biomechanical upgrades inoculate the athlete, allowing them to sustain crisp, explosive technical connections, even in the final, exhausting seconds of a routine. We can extract the study's exact training parameters into a highly specific integration protocol for your programming. First, optimize the training volume. Run these sessions exactly 3 times per week, strictly capped at 60 minutes each. During these specific conditioning blocks, completely remove any low-intensity, steady-state cardiovascular work. Next, discard isolated machine exercises. They simply do not replicate the demands of the sport. Instead, program the multi-joint functional movements utilized in the study: clean and jerks, Romanian deadlifts, and single-leg squats. Pair those lifts with weighted, sport-specific plyometrics, like jumping whirlwind kicks and outward leg swings in midair. Utilizing complex, multi-joint drills ensures that the physiological load experienced in the weight room is an exact match for the mechanical stresses of the performance mat. Finally, we must properly regulate the execution intensity to force metabolic adaptation. Coach using internal load markers, demanding that athletes hit and sustain 90% of their maximum heart rate during active blocks. Utilize rigorous interval structures, like 90 seconds of maximum output followed by just 10 seconds of rest, to intentionally overload the system and build lactate tolerance. Relying on moderate intensity training will build general baseline fitness, but it leaves athletes highly vulnerable to the acute metabolic fatigue of competition. High-intensity functional training engineers the precise, fatigue-resistant explosive power required to execute elite maneuvers. By aligning the intensity of your conditioning with the brutal reality of the sport, you systematically eliminate the late-stage technical errors that cost